So here is the main idea of Danish pastry. Anon says, if I start this piece of dough and I fold it a few times, I'll get something that's thinner. And roughly speaking, if I fold it once, you'll have 2 layers. If I fold it 2 times, you'll have 4 layers. But I have to make sure that I'm stretching enough. So in general, maybe there are fewer than 2 to the n layers, but they're at most 2 to the n layers. And on says, if I do this in reverse order, so if I invert my equations, then what used to be stretching back in time will be squashing. So stable, unstable manifolds will interchange their roles. So if you just do that experiment, if you don't want to think, you can do it on computer, you'll find out that, for example, going backwards, the same piece of dough folded once will look something like this. So when it used to be stretching and contracting, if I go in reverse, then it's stretching this way and contracting that way. And Smale has, if I'm interested in long-term dynamics, then things that went 2 times forward in time, so I have my whole state space, but now I'm doing something on it, squish and squashing. And in that state space, there are these little regions which have a property that I know if I'm this region. I know that I had the past of being folded twice, and I have a future of being folded once, because past and future work like this by infinity. So I know that topologically, if I can describe this stuff, I know that if I'm interested in long-term dynamics, whatever long-term dynamics, it has to be in one of these regions, because everybody else is out. It doesn't have the future and the past we want to do. In the future, I got very thin layers where I'm allowed to be. In the past, I got very thin layers where I'm allowed to be. And if I'm looking at long-time dynamics, I came from somewhere going someplace, I'll end up in some little regions, and that's where the dynamics will be. So now the Danish pastry says, okay, our kneading theory for this problem. Find a map that only takes care of the stuff that it's there and doesn't care about all this crap inside. And the way you do this is that you make a map in which, if you start with a volume forward in time, this volume will get stretched by a factor 1/2. And then you apply your knife here. And I have the original figure, but physical review removed the knife, so we are not on. You apply the knife, and then what you do, you pivot this thing. So call this region A and B. So originally A is everybody who got squashed up to here, and everybody who was here got squashed and pushed all the way out there by factor 2. Now you pivot it. So this is stretch, fold. Just cut it here, pivot around this point, so you get B upside down. Now what we have a map of a square into itself. And you'll be glad to hear it's Hamiltonian in this case, because area is being preserved. So now, these things here that we have in this picture it says when I go twice forward in future, then I'll have 2 layers on each one of them. And when I go once backward in future, I'll have a layer here. It's 2 layers backward. And then this square will have a unique address that's here. This guy will have unique address that's here. This one will have its address here, etc. So now you have produced a nice tight map with no holes, because it just shrunk all the holes between them and increased these little squares until I have a very nice Manhattan map of what's complicated nonlinear dynamics, stretching and folding. And And then there'll be some confusion, because this one, you don't know what's going on, because it doesn't seem to be, it's only partially separated in this intersection. To understand what happens here, we'll need a theory which in American colloquial is called prune Danish. And a few weeks ago we were all Charlie Hebdo, and this week we are all Danish. So people who are not taking this course have too much hand on their time, because they're causing mischief. Prune Danish is the theory of figuring out what happens to the things that are not nicely sliced by future and the past. And to do that, you have to fold one more time to get more resolution. So it'll turn out that there's something here. And pruning, which we found in one dimension for Needing's theory, now will be a two-dimensional area that will contain all inadmissible orbits.